Hey there! Welcome to our exciting journey through the wonderland of glycolysis. Today, we'll break down the essential steps of this amazing metabolic pathway and discover its crucial role in keeping our cells buzzing with energy. So, what's the deal with glycolysis? Think of it as the ultimate energy production line, where glucose, our primary energy source, is transformed into pyruvate. This magical process not only generates ATP, our cell's power currency, but also produces NADH, key player in other metabolic adventures. Why is glycolysis a big deal? It's a universal process, happening in the bustling cytoplasm of all cells, providing the energy needed for various cellular shenanigans. Without glycolysis, our cells would be left stranded without the vital energy they need to survive and thrive. Ready to dive deeper? Let's explore the magical steps of glycolysis and see how this fascinating process unfolds. Step 1. Glucose to glucose 6-phosphate, G6P. Our journey begins with glucose, the star of the show. In this first step, the enzyme hexokinase, or glucinase in the liver, swoops in to phosphorylate glucose, using ATP to form glucose 6-phosphate, G6P. This clever move traps glucose inside the cell, ensuring it can't escape. Mnemonic: glucose gets a gatekeeper. Step 2. Glucose 6-phosphate, G6P, to fructose 6-phosphate, F6P. Next up, glucose 6-phosphate, G6P, undergoes a transformation, thanks to the enzyme phosphoglucose isomerase. This enzyme performs a little molecular magic, rearranging G6P into fructose 6-phosphate, F6P, setting the stage for the next big step. Mnemonic: Fred got a glimpse. Step 3. Fructose 6-phosphate, F6P, to fructose 1,6-bisphosphate, F1,6BP. Now, things get serious. The enzyme phosphofructokinase 1, PFK1, steps into phosphorylate F6P using another ATP, creating fructose 1,6-bisphosphate, F1,6BP. This is the rate-limiting and highly regulated step, making it the main control point of glycolysis. Mnemonic: F1,6 is funded. Step 4. Fructose 1,6-bisphosphate, F1,6BP, to glyceraldehyde 3-phosphate, G3P, and dihydroxyacetone phosphate, DHAP. In a dramatic twist, the enzyme aldolase cleaves F1,6BP into two 3-carbon molecules, glyceraldehyde 3-phosphate, G3P, and dihydroxyacetone phosphate, DHAP. This split paves the way for these smaller sugars to continue their journey. Mnemonic: F1,6 bisects. Step 5. Dihydroxyacetone phosphate, DHAP, to glyceraldehyde 3-phosphate, G3P. Triose phosphate isomerase then works its magic, converting DHAP into another molecule of glyceraldehyde 3-phosphate, G3P. Now, both molecules are ready to move forward. Mnemonic: DHAP doubles down. Step 6. Glyceraldehyde 3-phosphate, G3P, to 1,3-bisphosphoglycerate 1,3-BPG. The enzyme glyceraldehyde 3-phosphate dehydrogenase, GAPDH, takes the stage, oxidizing G3P and reducing NAD+ to NADH. This forms 1,3-bisphosphoglycerate 1,3-BPG, adding a high-energy phosphate group in the process. Mnemonic: GAPDH gives NADH. Step 7. 1,3-bisphosphoglycerate 1,3-BPG, to 3-phosphoglycerate 3-PG. Phosphoglycerate kinase is up next, transferring a phosphate from 1,3-BPG to ADP, producing ATP and forming 3-phosphoglycerate 3-PG. This is one of glycolysis' big ATP producing moments. Mnemonic: 3-PG gains ATP. Step 8. 3-phosphoglycerate 3-PG, to 2-phosphoglycerate 2-PG. The enzyme phosphoglycerate mutase then rearranges 3-PG to 2-PG, prepping the molecule for the upcoming dehydration step. Mnemonic: 3-to-2 switcheroo. Step 9. 2-phosphoglycerate, 2-PG, to phosphenyl pyruvate, PEP. Enolase steps in to dehydrate 2-PG, forming phosphenyl pyruvate, PEP. This creates a high-energy enol phosphate linkage, setting the stage for the grand finale. Mnemonic, enolase evaporates water. And now, we've arrived at the grand finale of glycolysis. In this climactic step 10, we witness the enzyme pyruvate kinase in action. Imagine pyruvate kinase as the master of ceremonies, orchestrating the final transformation. This enzyme facilitates the magical conversion of phosphenyl pyruvate, PEP, into pyruvate. How does this happen? Phosphenyl pyruvate, PEP, generously donates its phosphate group to ADP, creating ATP, the very essence of cellular energy. This pivotal exchange not only produces ATP but also forms pyruvate, key player in the metabolic game. Let's paint a vivid picture. Imagine PEP as a sparkling firework, ready to explode. As it hands over its phosphate to ADP, it bursts into a brilliant display, forming ATP and pyruvate in a flash of biochemical brilliance. This moment is perfectly captured by our mnemonic, PEP pops pyruvate. Thank you for joining me on this fascinating journey through glycolysis. I hope you found this exploration as thrilling as I did. If you enjoyed this deep dive into the molecular world, don't forget to like, share, and subscribe for more captivating content. Stay curious, and until next time, keep exploring the wonders of science.